My repository had 127 markdown files, and I trusted exactly none of them. The docs claimed 28 modules. There were 70. So I sent in a swarm of AI agents to read everything and design a fix. This is a dynamic workflow, and it's probably not what you think. It is not one chatbot grinding through a long conversation. It's a small program. Claude writes on the fly and runs in the background. It fans out a fleet of narrow AI agents, then stitches their findings into one answer. The rule that makes it work: orchestration by script, reasoning by agent. The control flow is plain code. The judgment inside each step is the model's job. So how is that different from subagents or skills? It comes down to one thing: who holds the plan? With subagents and skills, Claude is the orchestrator, and every result piles into its context window. A workflow moves the plan into code. The loop and the results live in script variables, so Claude's context only ever holds the final answer. That's how it scales to hundreds of agents without drowning. Here's how I started it. I typed one word: workflow. That's the trigger. It's opt-in by design, because every agent spends tokens. No keyword, no swarm. For my cleanup, the script spawned 14 agents. 6 read the docs, clustered by area. 5 read the real source code: the core, the gateway, the front end, the schemas, the bundles. Why fan out? One agent reading everything at once goes shallow. Keep each agent's context small, and it can actually reason. But parallel agents aren't the magic. This is. I made the agents argue. One architect agent proposed a new doc strategy. A separate critic agent was told to attack it, find the over-engineering, find the broken assumptions. The critic caught 3 facts the architect had invented. A single agent would have shipped them as truth. Parallelism gives you speed. Adversarial review gives you trust. Here's what the agents actually produced. Every document gets one home for its stage in life: draft, then spec, then archive. Never 2. One source of truth per fact. No orphans. Every spec carries a dated status line. And here's the real lesson. A strategy in a document is just more rot waiting to happen. So the fix has 3 layers. Agents find the mess and design the fix. That runs once. A dumb script catches mechanical drift on every run. And a git hook stops drift at the source, automatically. Agents for judgment. Scripts for memory. You pay the heavy agent cost once, then maintenance is basically free. On the real repo, 2 dead links, gone. 7 orphan files, gone. 14 missing status banners, added. The audit went from 31 failures to 0. And the next time something drifts, it shows up in seconds, not 6 months. Now the part nobody shows you, the bill. This session ran about 2 hours and burned roughly $51 of API value. I'm on the max plan, so that was 0 out of pocket. But multi-agent runs are genuinely expensive. Each agent fires its own requests, and most of this ran on a huge context window. I even hit my usage limit and had to resume. The save was simple. The agents had already written their answer to a file. A workflow doesn't remember across sessions. The file did. So that's a dynamic workflow. A swarm to find the mess and design the fix, then a dumb script and a hook so it never comes back. Don't ask one AI to clean your code base. Use many to think and scripts to remember. Next time, I'll measure what slimming every session actually saves. Subscribe if you want that number.